Hi, I'm David, and welcome to EV World News. We're talking about electric vehicles, green energy, and the stock markets. I'm here today with engineer Mike Herzog. How's it going, Mike?
Great. Glad to be here, David.
Oh, thanks for joining us today. So, Mike was AWOL last week, and so I want to
It's
hear about what your excuse for not being here last week.
so
This
I
is pretty important.
for me, I was in Costa Rica with my family for 10 days on a nice vacation, but now we're back. And what we were talking about beforehand was something I found very interesting, besides, jungles and beaches and everything like that, was the amount of electric vehicle infrastructure charging and electric vehicles down there. I was able to see in person at a dealership, a BYD Seagull, a tiny little thing in bright green, lime yellow or lime green. Couldn't miss it in what it was, but it was clear. It was a nice looking vehicle. It's what you would expect to see size wise from all the advertisements, but within some of the cities in the northern part of the country, there was noted electric vehicle charging stations. The hotels and resorts and places we stayed at had access to electric vehicle charging, and even in rural Costa Rica agrarian economies, I'll be damned if I didn't see one of them pop up and say, "Here's just a random EV charging station that was built out there." So it was different to see that what you maybe wouldn't expect in a Central American economy and places where gasoline infrastructure is limited. Even there was EV charging available in those locations.
I have a lot of people who don't believe me when I tell them that for much of the third world, there people have more access to electricity and finding an electric jack than they do access to a gas pump.
Yep, it was
And
100% true. 100% true. Now, I will say there's a lot of blinks, a lot of short outages, a lot of some of the hotels you could hear the
mhm.
generators kick on because of the
Oh wow.
infrastructure, but it came right back. They were able to make the fixes, but gas stations were very few and far between. But access to electricity, it was pretty prevalent and well maintained. That's what I do. I look at the lines everywhere I go and say, "Ooh, what's that? How bad is it? What does it look like?" And it was modern. It was updated infrastructure. All the trees were cleared. You could tell where they'd been replacing poles. All the things out there. It was really well set up for it.
Now, so they probably haven't had that electrical infrastructure like we have in the United States, where we've had it for 120 years and
Mhm.
things like that. So the fact that maybe it's been put in the last 20 years look,
It's new.
pretty
Yeah,
modern. Yeah.
it looked good. We're in Nebraska here, and you drive down some county roads around here. Some of those were from the old, 1920s electrification plans, and they're still standing. But yeah, these
Now,
these newer countries where they're putting it in new, it's done right. It's done well. It's new equipment.
and when you're talking about seeing that BYD Seagull, that's an under $10,000 car right now.
Mhm.
And you can't buy them in the United States, but you can buy them in probably about 60 countries, 80 countries, something like that. And this is what's going to happen to the EV industry. We're going to see lots of these cars in some way coming to the US at some point. It just
Yep.
may not be BYD, but somebody is going to make something that's going to be inexpensive and sell it here,
Yep.
in the US. And here's what he's talking
Yep.
about.
That's
Now,
the one.
here he says here it says an $11,000 car, but the US dollar has strengthened and that car is now about $9,800. And it's just really hard to fathom. That's a four-door electric car.
Mhm.
It was about the same size as a Mini Cooper, it looks like.
But yeah, about Mini Cooper size, maybe a little bit bigger, but equivalent. I mean, it's not a large vehicle. No, not at all. But
I've always felt the Mini Coopers new at, they're like $35,000. I've always felt they should probably be more like $12,000.
lower, right? That was when they first came here. That was a big surprise for everybody when you saw the price tag. So,
Right.
ooh, a mini vehicles. Ooh, that's
Yeah. Yeah. They
not a
were
winning price
expensive.
tag.
No, it just a little bit different, but I appreciate you sharing that with us. So I want to real quickly touch on something because we talk about electric vehicles, but part of our show is green energy. And while I do get some pushback on green energy is kind of a funny thing because we get pushback on this, and people don't realize that green energy is actually cheaper and it's being implemented all over the world, not because everybody is listening to Greta Thunberg or, other people espouse all these green
Mhm.
projects. It's because in the long run, it's cheaper than coal, it's cheaper than gas, and there's a lot of things these countries can do to control their own infrastructure. Part of it is everybody that doesn't have gasoline and has to import it would like to be independent of that,
Yep.
and so if they can create their own energy, they want to do that and not be dependent on some country that might invade them in 10 years.
Well, and it's everybody always respects the other green, as long as
Yes.
the dollars and cents make sense, and that's exactly what you just said. Once that scale tips in favor of it, it's ooh, like this is the way to go.
So this is Algeria breaks ground on the first project of a 2 gigawatt solar program. And this initial section is on 988 acres and it's going to be 200 megawatts. And I've done this math for other people. So essentially 5 acres of solar panels is equal to about 1 megawatt. Okay.
Mhm.
And of course, you're only generating that, in daylight, and there's certain hours of the day that are better than others. But I just kind of wanted to bring this up because we try to cover some of these issues with green energy and what's going on. But it's not just because people want to greenwash everything. There's other legitimate reasons for people wanting to do solar and wind projects. And in the United States, I think solar and wind have passed up coal. I'm not
Yeah.
100%, but it's right about the same amount of power. Because I get people all the time. I remember somebody saying it's like it takes 100 pounds of coal to fuel that Tesla,
Mhm.
and it's like, well, that actually is true. If we were using all coal, one pound of coal is equal to 1 kilowatt hour of energy. If it's run through a coal processing plant that's max efficiency,
Mhm.
okay, and so if you have 100 kilowatt hour Tesla battery at 100%, you have essentially 100 pounds of coal. But the truth is, we only get 20% of U.S. power from coal.
It's amazing when you look at the graphs of coal production over time that the Department of Energy puts out. It has gone straight down. Now it hasn't all been green. A lot of it's been wind and solar, but natural gas has also picked up a lot of that slack as it's gone
Mhm.
through, just because it's so cheap,
Yeah.
and effective and reliable.
People always try to tell me, oh, EVs aren't clean because they have to be powered by coal. Well, the truth is, coal is very dirty. Okay. So it's not just a matter with the carbon emissions, you have just the particulates in the
Yeah.
atmosphere. And I saw studies on how since 1980 to today, how many hundreds of thousands of lives have been saved because as coal usage has gone down, more people are living and surviving in the areas near where coal was being mined. It's where it's being, or not where it's being mined and burned for energy.
Yeah.
People were having all kinds of lung problems and dying horrible deaths from that. And it's just a different,
Yeah, I
thing to look
think it
at.
was I think it was just last month in March for the first time ever, energy production from solar, just solar by itself, passed coal in the state of Texas.
Oh
Um,
yeah,
which is, I know Texas, people will look at that and it's a huge natural gas state for production too, but that's a huge threshold. Wind's been up there for a long time, but to see solar by itself pass is that's a big deal in Texas.
it's interesting because Texas is number one in the United States in production of oil and gas. Okay.
Mhm.
And I don't know if they have LNG. I know they have oil and gas, but they have nuclear, they have wind, and they have solar. And they have a little bit of everything. And they have I think they have more solar now than California.
I believe it. Yeah.
And California, and if you go to California, I'm not a big fan of the windmills. Okay. I don't think they look pretty, but that's a different story. Whereas the solar farms, you can kind of hide them out, in a
Mhm.
field somewhere, and they're not quite so obvious. They're not towering up there like the windmills that go hundreds of feet in the air. But if you drive from like LA to Palm Springs, they're everywhere. So like they line the roads up and down the roads through there, through that
Mhm.
corridor. And, it's not, it's kind of cool. I guess, if you drive through Kansas, you see all the oil rigs
Yeah.
by the road, but it's just not as, you know, intrusive, I guess, as the big wind
That's right.
turbines.
Yeah, yeah.
Yeah,
That you can see from many, many miles away because they put them up on a hill to catch the wind and they're tall anyway. Yeah.
yeah. So my next topic is about an aircraft being built called the Radia Windrunner. Be the world's largest cargo plane. Now, what's not specified in the article is if it was bigger than the Mirya, which was the Antonov 225 that was designed to haul the Soviet space shuttle, which was the largest cargo plane in the world until the Russian invasion of Ukraine ended up destroying it because it was based out of a Ukrainian airfield. So it was owned by a Ukrainian company. But so there was the Antonov 225. There's still 4 or 5 Antonov 124s flying around, and the 124 is about 20% larger than a C-5 Galaxy that our military uses to haul around equipment. Those things are massive. You actually have to, if you go in, I haven't ever been in one of the Antonovs. You go into the C-5, you have to take a ladder up to the cockpit.
Oh, they're great. Well, you drive tanks on them.
Right. Yeah, they can haul I think they can haul 2 Abrams tanks. It's
Mhm.
crazy to think you've got 120 tons just in those 2 tanks, how much power you could get in there. Bill was telling me he wanted to get a Rivian R2, and he
Mhm.
was trying to figure out how to get it back. And I said, well, you could get a Chinook and you could strap it to a
Just
Chinook
fly
and you
over.
could just fly it all the way back. And go, that would just change the carbon footprint of that Rivian by slightly. But
You'd have to catch up. You have to catch up on the curve.
yeah, he'd really have to get a million miles out of the Rivian to catch up from the Chinook.
It's for hauling wind turbine blades. It's actually kind of interesting because that's the limitation today for land-based turbines is you have to haul the blades over land, and at a certain distance you can't make turns.
Yes.
It's too big because it's you can't have a joint access or anything. It has to be one solid, and it's really limited the size on where we're at now. Offshore, where you can haul it on a cargo ship, yeah, you can go a lot bigger, but overland, that's what we're stuck with. So the idea that they're going to put this so we can build giant honking wind turbines somewhere, that's the approach we have to take.
I'm amazed when I see one of those trucks go by with a wind turbine blade on it, and you've got the tractor trailer, you've got the little small trailer with the front end is on it, and then the whole blade just stretches for like 50 yards, 100 yards. I think it's 50 yards. I'm not sure exactly how big those ones are. And then it has another trailer at the back that the rear is sitting on, and seeing it try to be straight the whole way through going down the road. And I'm just like, well, thank God they don't have to make any turns, you
Yeah,
know, because that would just be
I will
nuts.
tell you, I don't think you would find a developer that would ever admit this, but there have been certain projects where you get down to it and the final logistical piece of how the heck are we going to get this here, and you have a tiny little limitation in a road path, and the project changes drastically because we went to haul it and we were ready to go. It's like we can't get clearance on this road. To make the sharp turn or to go down the hill or whatever we needed to get there. And it kind of blows up real quick.
So this Radia Windrunner will have a cargo volume 10 times greater than a 747. That just kind of puts it in perspective. And it can hold a nearly 350-foot wind turbine blade.
Wow.
That's nuts. That would mean that if you had one up, one down, that means you have a 700 plus foot to the top.
Mm-hmm.
That's just seems astounding. Wind farms are typically built in remote locations. The plane will be capable of landing on short, unpaved airstrips.
How?
I
Just
don't
that
know.
much
I guess it's
stuff.
going to have to be really ruggedized. Maybe be part of the design. Let me see. The engineers are following the mantra of do nothing new. The plane is built using existing technologies to ease the engineering and subsequent certification process. but Radia will be an energy company building clean energy projects. Its fleet of cargo planes will simply give it a strategic advantage. Think of us as an energy company with a unique way to supersize turbines.
Mm.
That's interesting transport thought. I've had some discussions about doing solar farms in some African countries, and I am, sometimes kind of curious how, getting all the correct infrastructure, all of that down into some of those projects, how that may play out. And these guys are going to fly
Yeah.
these in. I mean, that's, I guess that's the only, real way to go. Let's see here. See what we've got here. So often, energy and climate technology conversations can get stuck on the market as it exists today, and even innovation is often portrayed as somewhat straightforward. Wind turbines get bigger, solar panels become more efficient. One of the things here is everybody always wants to talk about, well, EVs, they take a couple of years. Everybody thinks that it takes EVs like 10 years to, cover up their carbon footprint from when they were built, but in reality, studies are showing it somewhere between 1 and 2 years. But in this particular case, where they're taking these wind turbines, these people just want power, and this is a way that they can have control over their power infrastructure when they don't have any other source, and they don't want to do coal, and they don't want to do light natural gas, or or oil, or any of those. And so this makes sense for them. The biggest wind turbines are as long as a football field and simply too big to be transported to the fields and deserts where they're typically installed. Wow. It's just hard to fathom that's going to be such a big aircraft. Yeah. Let's see here. So a company called Giga Storage is building a 600 megawatt battery complex in Belgium. This is kind of what it looks like. These are just big battery pods being installed. Dutch energy storage developer Giga Storage, it'll add 600 megawatts, 2,400 megawatt hours of energy storage capacity in Belgium and create Europe's largest battery site. It wasn't that long ago we were talking about Tesla doing the thing with Hawaii, where they replaced a coal factory with a battery farm. And let's see, this battery complex will cover the average energy consumption of 330,000 families daily. And so it'll be pulling renewable energy, storing it in the battery farm, and then supplying that.
Yeah. I mean, that's a great grid asset from a grid planning standpoint. Something that large actually can make a difference. And instead it was 1,200 megawatt hours. So it's not like, okay, we can run this for 15 minutes. You could actually run it for a couple of hours at full capacity to give people a chance to bring a power plant back online, let the wind forecast or solar or storm front, whatever it is, pass through. You could actually do that.
Why is no one working on safer blimps? Well, I think they have. I mean, if you look at, the Hindenburg disaster was almost, what was that, 90 years ago, and Germany only had access to hydrogen. And we're not categorizing hydrogen as being super explosive, because we want to use it in planes and cars and boats. But helium is only available, I think, in North America. It's not available on the whole planet. And so the United States, I don't think we're real big on exporting helium, but there's some reason why it's kind of unique. So all of the blimps in the United States are generally powered by helium. And so that's a little bit different, but helium's far safer. But yeah, I guess you could strap some turbine blades to some blimps and carry around. When I visit Arizona, there always seems to be people flying around in hot air balloons. And it's just not something I just ever care to go do. I don't know. Yeah, helium, I'm sure, is far more expensive than hydrogen.
Scarce. It's becoming more scarce than it was at one point too, which is probably why it's more expensive.
Right. All right. So anyways, what was I got kind of sidetracked there. All right. So I've a couple times had some involvement where I've been trying to help some groups do forest conservation. And I don't know, are you familiar with timber rights and selling timber? So
A little
typically,
bit. Hmm.
if you're going to build a subdivision and the land is currently forested, you would buy the land and you would have some folks come in and do what's called a timber auction. So a timber wholesaler would come in and they would um, all bid on what they think that timber is worth, and then whoever's the high bidder gets to come in and they come and they cut your timber, and then they pay the folks that organize the auction, they pay them some premium on top of that. And but what's happened is places have put out carbon credits to prevent forests from being cut
Hmm.
down. So these numbers keep dropping. So the number nature conservation carbon credits hovered at near $3 US, which is a record low this month, a drop from $15 in March of 22. So that's an 80% drop in what people are paying for forestry related carbon credits. And I don't know exactly what is doing that. It says part of the challenge is in helping project participants understand complicated numbers on uncertain market pricing and how carbon credits are generated through modeling deforestation rates.
Hmm.
Yeah, so I've seen several efforts to help, say, Indian tribes here in the U.S. that own large amounts of forested land up in the Pacific Northwest. And, um, it's just kind of a different thing. And I just thought I'd report that because it just seems odd that that price has gone down by 80% here in the past,
Yeah,
little over a year or 2 years, 2 years.
I'm trying to think why that may be, or if there's any impetus, or the idea that the carbon, you know renewable energy credit market, anything like that, is experiencing similar change. I don't believe it is.
I haven't heard much. The United States started doing carbon credits with the Inflation Reduction Act.
Hmm.
And so I know there's been a fair amount of that because I've been in discussions where oil companies were looking to pump carbon into places where they had previously, pulled all the oil out of.
Yeah.
And so it was a way to get more usage out of the land that they had
Hmm.
rights on. All right, let's go ahead and let's get to this blade battery. So this is an article somebody sent me on LinkedIn. And this blade battery, I like it has the vampire blade up here, as the icon, cutting up a bunch of little AA batteries. But I don't know if batteries really bleed. He's got blood on his sword. Anyways, um, and I'm sure that was probably drawn with AI, but it's actually a pretty decent job. But let's see. This is by Dr. Ivana Velichovic. I don't know. I'm probably butchering her name. But so one of the big issues people always have is with EVs is they're always talking about range anxiety and issues like that. Well, the idea here is they want to get rid of cylindrical cells and improve the usage of space within the battery pack and how it's utilizing energy. And the round shape inherently suffers from poor packing efficiency.
Fair enough. I mean,
Yeah.
it creates space between it. I mean, that's fair enough.
Let's see. So to quantify this, consider a traditional battery pack using cylindrical cells can achieve a VCTPR of around 40 to 50%, sometimes less than 40%. This means in the best case scenario, only half of the volume of the battery pack is actually used to store energy. The rest is effectively dead space. Now, further down the article, they start showing what the blade storage might look like, and it would look kind of like this. So we'd have flat against
Hmm.
flat. Now, we're also talking about the efficiencies of lithium ferrite phosphate batteries. I see so many things coming out in battery tech, and we talk about the sodium ion batteries, we talk about solid state, LFP, all these different ones. I mean, obviously, you don't hear about electric cars catching on fire anymore. And generally, if you do, it's one that may or may not have actually been the car catching on fire. It may have just been somebody just torching it, you know, and that was something that really was a problem
I
a
think
few
that
years
mania
ago.
has finally been put to bed.
Yes.
It's no more than any other vehicle. I mean, it's even less so. I mean, it's tried to
Well,
define it, but
according to insurance, it happens in EVs at 1.6% the rate of gas cars. It's something like 1/60th
yeah,
the
yeah.
rate. And but we always hear about, well, there was a fire in a gas car out in California,
Mhm.
or something. It's like, well, so
Yeah.
what? I
I,
mean,
I like this. I'm with you. I've been following chemistry, technology, and batteries for a long time. And for every time there's been a breakthrough, or hey, we finally figured it out, that gap between a laboratory breakthrough and actual commercial production and repeatability has just never been there. But I think it's always funny where, from your battery that you plug into your cordless drill, up to an electric vehicle, it's effectively a bunch of AA batteries that you
right.
buy and you put in there. And so this idea of, okay, we're going to try to optimize how we actually pack that into the space and change the battery design, even if it was a hexagon or an octagon, or something and not round, where you think of those puzzle pieces start to fit together really closely and can maximize that space better. Is that a simple solution to something like this? And can you start to put it together? But yeah, it's going away from 1,000 AA batteries powering your car in a space like that to maybe a different design, which is a
So
unique approach to it that I hadn't really thought about before. But from a density perspective, like, great, if somebody figure out that math.
So part of their design is also in. So we talked about the skateboard before, right?
Mhm.
And I got to feel, well, how's that different from a chassis? Well, in part of this, in the skateboard design, the battery is actually going to be integrated into the chassis. Okay, so it's not just going to be placed on the
Sit on
chassis.
top.
They're
Yeah.
talking about it replacing part of the chassis. Okay, so what it'll do is it'll reduce weight of the vehicle while at the same time increasing energy density, and they compare it to a suit of armor that's both lighter and more robust.
Mhm.
And so you know, when I tell people about people walking away from 80-mile-per-hour crashes that where they did in an EV, and they shouldn't have walked away, it's crazy because the EVs are absorbing so much of the impact, and you just don't get that with a gas car the same way. And um, that's it's just the way things are changing. Anyways, I thought that was a good article that somebody
Yeah.
had sent me from LinkedIn.
I like that one. I like that one a lot because it's not the alphabet soup of elements that we put together and, oh, here's the new tech chemistry breakthrough. It's simple. How do you pack your suitcase better?
All right, so now it's time to play the blame game. Who are we going to blame for our problems? All right, let's pick on Asia, okay, because Asians don't get enough complaints. All right, Asian major fossil fuel majors responsible for largest emissions hike since the Paris Agreement. This is from a study. Of course, you see the haze. This is
Indonesia,
Jakarta in
Jakarta.
Indonesia. Most polluted city in August 2023. I'm sure they're cheering like, yeah, we're number one. Yeah. But anyways, let's see. A study by Influence Map, a London-based climate policy think tank that traces industrial emissions since the 1850s, finds the majority of global carbon dioxide emissions produced since the climate accord can be linked to a small group of large emitters that have shown no signs of slowing production despite global pressure to decarbonize. Out of 100 companies featured in the study, 58 produced higher emissions in the 7 years since the Paris agreements than it did in the same period before that. Most pronounced in Asia, where 13 out of 15 carbon majors in the study ramped up climate wrecking emissions post Paris. 5 investor owned Asian carbon majors and 8 out of the region's state owned entities, included China's National Petroleum, Coal India, are linked to higher emissions post 2016 than pre 2015. Asian firms' emissions have increased by 7.4% since the Paris Accord compared to the 7 years before. Didn't China say they were going to start getting on the stick in about 2040?
I don't remember.
I mean, I just, it's just kind of interesting to see. North America, home to oil and gas giants ExxonMobil, Chevron, and ConocoPhillips, is the only region where less than half of its carbon majors, 16 out of 37, increased emissions, less than half increased emissions after the landmark accord. So we'll give that as something
my
a little better in North America.
Behind these, and is this relative or is this a raw number? Because it's one of those, if it's a raw number, you kind of look at it and say, well, yeah, there's more people. Jakarta and other Asian cities are growing exponentially, in these spaces. So I don't want to say, well, duh, it's emissions are going to increase while even if you're changing the relative amount, the raw amount is going to go up with the number of people that are in these areas and the amount of industry and everything like that. So I wonder, I'm taking this one with a grain of salt until I could learn more about where some of these numbers come from. Because yes, emissions increase as we get more people.
So here's the big carbon majors, but measured by metric tons of carbon dioxide since the Paris Agreement of 2015. All of them are state-owned. Now, we've got Aramco, National Iranian Oil, number 2, Coal India, China National Petroleum, Abu Dhabi National Oil, Kuwait Petroleum, Iraq National Oil, Petronas, which is in Malaysia, Qatar Energy, and Pertamina in Indonesia. These are all not companies, I guess, that you would really think about, right?
Mm-mm.
Most of us as Americans, other than I'm familiar with Aramco, but the others, I don't even know them. And so it's interesting just to see that they've had almost an 8% increase since 2015 versus going the other direction.
Mm-hmm.
Let's see. Oh, Saudi Aramco, Russia's Gazprom, and the National Iranian Oil Company, all of which are state-owned, are the largest 3 contributors to global emissions globally. All of Asia's 10 biggest emitting firms are state-owned, so are more insulated from investor pressure to decarbonize.
Makes sense.
Oh yeah, China and India have committed to decarbonize by 2060 and 2070. So China by 2060 and India by 2070. Yeah, that's a long ways out. That's giving them damn near 50 years. 40 years for one, 50 for the other. Yeah, I just thought that was a good little article.
It is nice. I mean, it's interesting, maybe not nice.
Yeah, well, yeah, it's certainly not great news. I got one. Oh, I just lost my camera. Let me see. Let me get back in there. There we go. So I have one more, and this is something I heard Musk talk about recently, was AI is growing so fast that there will not be enough electricity in the world starting in 2025 to power all the computers that AI is going to require. And so forget, people talk about EVs going there. That's not the big one. People are saying that all the data centers trying to go online are really the big users of electricity. Amazon just bought a nuclear power plant.
Mm-hmm.
So, they're, on that way as well. AI's rapid growth poses a challenge to big tech's clean energy efforts. And big tech companies have been trying to become carbon neutral. A lot of them, when they're putting in data centers, they're having
they'll have a
solar farm put in.
Yep. They'll have, at the same time, they'll buy the rights to the output of a planned solar farm or wind farm, and they'll claim that as credit. Hey, we're 100% green, we're 100% renewable for this facility.
Right, and it's tech companies are concerned about having enough energy, not just clean energy, to power their AI-driven ventures. Industry leaders are considering nuclear as a potential solution to meet the tech's sector's massive energy needs without hindering decarbonization goals. It's just nuts to think that at this time when we hear all these people talking about, oh, the grid won't be able to handle EVs, it's like, well, you got a bigger problem coming up, you know.
It is, and we see this locally where we're at, where our local utility has been stressed and adding new natural gas facilities, in addition to all the renewables because of large data center growth. And we locally, the utility will take some hits on it and say, why are you adding natural gas? We're supposed to be moving to this direction. And it's because of this data center growth, and it supports everybody. It supports the world, that we're looking at. We've got, in eastern Nebraska, some of the largest companies in the world, your Googles and Facebooks locate here because of our affordable power and access to wind and everything like that, because it's growing so dang fast.
So the training process for GPT-3, which is the predecessor of ChatGPT, required 1,287 megawatt hours of electricity and 10,000 computer chips, which was enough to power 121 homes for an entire year and produce 550 tons of carbon dioxide. Now let's see where we get, because the other thing is crypto is back up,
Yes.
so there's more people are
there, and the mention of it. Crypto farming's the precursor to all of this, where you're running algorithms over and over and over again, and you follow the cheap power because that's your only expense.
a new data center comes online somewhere in the world every 3 days. Wow, I wouldn't have guessed. So that's roughly 120 a year. That timeline is not sustainable as no energy to power the new centers. Construction timelines for many data centers have been pushed back from 2 to 6 years due to issues with power supplies. Man, that's a big number. Industry insiders are betting big on nuclear energy to meet the tech sector's massive energy needs without hindering its decarbonization goals. Others are counting on innovation and technological advances to save the sector from itself. Let's see here. Sam Altman personally provided $375 million in funding to private U.S. nuclear fusion company Helium Energy, which later made a deal to provide energy to Microsoft. And he's also chairman of the board for nuclear micro reactor company Oklo, which may go public this year. It's just interesting to see, people didn't really want to talk about green energy or nuclear as green energy so much, but there's such a shortage of energy. It looks like nuclear is going to make a comeback simply because of, these things needed for, things needed for AI.
Mm-hmm.
And nobody's going to slow down the AI gravy train anytime soon.
That's left the station. That's out in the world right now.
Anyways, I appreciate you coming on today. I think that's all we've got to cover for today. And folks, we appreciate y'all watching and chatting. Oh, we had a question about what if the battery needs to be changed in that chassis? Well, the way it's being integrated, those blade batteries, simply, they basically plug in. They plug in, it can be taken back out. Now, I know they're saying that it's being used to strengthen the chassis, but I'm assuming that there's a way there that it's got some kind of film underneath, but the way the battery is designed, because they're all pushed together, it is going to make the chassis more solid, and it replaces some of the other needs from the chassis. So it should be actually fairly straightforward to replace those batteries. Just pull them out and swap the new ones in. Anyways, all right. Well, thanks for watching.